So, welcome back to Spaced Learning Science. This session will be on atomic structure and the periodic table from AQA Combined Science Trilogy from the Chemistry Paper 1. So, the key rules. Make sure you've printed out the booklet from the link below the video. That's a Google Doc. You can download it straight from there. And the idea here, stage 1, I'm going to talk, you're going to listen and watch. You don't write anything down, you just listen. You then take a 5-minute break. Then you come back. Stage 2, you're going to repeat the video, but you're going to go back to the start. I'll talk, you do simple tasks. You fill in the gaps and complete the simple calculations, and then you take a break. And then stage 3, you'll answer questions. There'll be slightly harder tasks. The answers will be available at the end as well. And these are the sorts of questions that you'll find in exam paper. So, stage 1, I talk, you listen, pens down, eyes to the front. Here we go. So, atoms, elements and compounds. All substances are made of atoms. An atom is the smallest part of an element that can exist, and atoms of each element are represented by a chemical symbol. For example, oxygen represents represents an atom of oxygen. So the letter O is its symbol. Na represents an atom of sodium. There are about 100 different elements, and elements are all shown in the periodic table. And here is an image of the periodic table. You should recognize that from your lessons. Now, compounds are formed from elements by chemical reactions. Now, compounds contain 2 or more elements chemically combined in fixed proportions and can be represented by formulae using the symbols of the atoms from which they were formed. For example, water is H2O, 2 atoms of hydrogen, 1 atom of oxygen. And you'll draw it like so. So 2 atoms of hydrogen bonded to 1 atom of oxygen. Another example is sodium hydroxide. For example, NaOH, 1 atom of sodium, 1 atom of oxygen, and 1 atom of hydrogen. NaOH, 1 sodium atom, 1 oxygen atom, 1 hydrogen atom. Now, mixtures consist of 2 or more elements or compounds not chemically combined together. The chemical properties of each substance in the mixture are unchanged. So within the mixture, the chemical properties are unchanged. They keep their chemical properties, even though they're now in a mixture. Now, mixtures can be separated by physical processes such as crystallization, simple distillation, fractional distillation, and chromatography. Now, we will go through all of these in more detail in a later lecture, though you just need to know these are physical processes and they can be used to separate mixtures. Now, these physical processes do not involve any chemical reactions and no substances are made. So, development of the atom. Before the discovery of the electron, atoms were thought to be tiny spheres that could not be divided. The discovery of the electron led to the Plum Pudding model of the atom. The Plum Pudding model suggests that the atom is a ball of positive charge with negative electrons embedded in it. Now, the Plum Pudding model of an atom. A ball of positively charged stuff with lots of negatively charged electrons scattered through it. And you can see from this diagram, there's positively charged stuff and there's negatively charged electrons. Whereas our modern model of the atom, today, this is the idea science had of the atom. There's a tiny positively charged nucleus with negatively charged electrons in orbit around it. Here's the positively charged nucleus, and the negatively charged electrons are in this outer space. Now, in 1911, this is the experiment showing positively charged alpha particles were fired at metal foil of gold atoms. Most of them passed straight through, showing that the atom mainly consists of nothing. Some were slightly deviated, showing that the atom had a positively charged nucleus. Whereas a few were reflected backwards, showing that the positively charged nucleus was tiny. So this experiment in 1911, they fired positive alpha particles at gold foil. Most went through, some were deviated, and a few were reflected backwards, showing that it was a positively charged nucleus and that it was a very, very small positively charged nucleus. Now, Niels Bohr then suggested that electrons orbit the nucleus at fixed distances, and later the proton was discovered. The proton was discovered by James Chadwick, and this is one of those names you just need to remember. James Chadwick discovered the proton. The neutron. James Chadwick discovered the neutron, and that was 20 years later. So if you asked who discovered the neutron, it was James Chadwick. So let's look at this modern structure of the atom. Atoms have no overall charge. In an atom, the number of protons is equal to the number of electrons. Now, all atoms of the same element have the same number of protons. And here's that structure of the atom. Nucleus in the middle, neutrons and protons, and electrons on the outside. But there's no overall charge because they have the equal number of protons and electrons. Now, the size of atoms. Atoms are very small, having a radius of about 0.1 nanometers. And the radius of the nucleus is less than 1/10,000th of that of the atom. Now, almost all of the mass of the atom is in the nucleus. Subatomic particles, you need to know the charge and mass of each. So a proton has a charge +1, neutron has a charge of 0, electron has a charge of -1. The proton's mass is 1. The neutron's mass is 1. But the electron's mass is very small. So let's look at this element, technetium. Now, technetium has 43 protons, and that number there is called the atomic number. It has 98 protons and neutrons in its nucleus. This is called the mass number, the 98. That's the mass number, the number of protons and neutrons. So this means it has 55 neutrons, because if I do 98 minus 43, it gives me 55 neutrons. Now, there are the same number of electrons as protons, so there are 43 electrons. Let's have a look at sodium. Sodium has 11 protons. This is called the atomic number. It has 23 particles in its nucleus. Remember, those are protons and neutrons. So that's called the mass number. So that must mean it's got 12 neutrons, because if I do 23 minus 11, I get 12 neutrons. And there are the same number of electrons as protons, so there are 11 electrons. Now, sometimes we have isotopes. Isotopes have the same number of protons, but different numbers of neutrons. So, this one here, this atom here, has got 6 protons, 6 neutrons shown by the blue, and its mass number is 12, carbon 12. This one here, it's got 6 protons, but it's got 8 neutrons, so the mass number is 14, carbon 14. These are isotopes, the same number of protons, but different numbers of neutrons. Right, we then got to go through electron configuration. So we know these electrons are on the outside, but how are they actually distributed? Now, the electronic structure of an atom can be represented by numbers or by a diagram. And the diagram looks like so. Now, this one has got 2 on its first shell, 8 on the second shell, and 1 in the last shell. Now, you cannot move out a shell until the inside shell is full. So, let's have a look. You need to be able to draw the first 20 elements electron configuration. So let's look at an example. 2, 1. You can have 2 on the first shell, up to 2 on the first shell, up to 8 on the second and third. So lithium here has got 3 electrons. It's got 2 on the first shell, 1 on the outer shell, so it's got 3 electrons, 2, 1. You can only put 2 electrons in the first shell. The second, third and fourth can hold up to 8. You can't put any electrons in a new shell until the one you're on is full. So 2, 8, and then so on. So let's look at another example. Sodium, 11. So I look at the atomic number. That tells me the number of protons. Remember, protons is equal to electrons. So if I want to plot 11, I'll put 2 on the first shell. I'll put 8 on the second shell. 2 plus 8 is 10. So that means I'll put 1 on the outer shell. 2, 8, 1. Left-sided carbon. Again, look at the atomic number. That tells me it's got 6 protons, which means it's got 6 electrons. So I put 2 on the first shell, 4 on the second shell. 2 plus 4, 6. So I've got 2, 8, 1, and 2, 4. And you can draw them like that, or you can write the numbers as shown there. Right, that's everything that we're going to go through in today's lesson. So, in stage 2, remember, you're going to pick up the pens and you're going to do more simple tasks. But what you're going to do as part of the video is you're going to pause this video. You're then going to go and take a break for 5 minutes. You're then going to come back and replay the first part of the lecture. Skip back to the start. And then when it comes, as you go through the lecture, you're going to fill in the gaps in that stage 2 of the booklet. So replay everything you've watched so far, but this time fill in the gaps. Make sure you go and take a break first. Go and do that now. Hopefully you've paused the video. Okay. If you've now continued watching, you're now on to stage 3. Again, if you finish stage 2, you filled in the gaps. What I now need to do is go take a 5-minute break. So press pause. You'll then come back and you'll have 15 minutes to answer the questions. When you press play again, you will be able to hear the answers. So, hopefully, you're only here if you've done stage 2. You've gone back, you've watched it again, you've filled in the gaps in the booklet. Now we're going to go to the questions and the answers. So, what are all substances made of? All substances are made of atoms. How are elements represented? With a chemical symbol. How many elements are there naturally? There are 100. Where are the elements shown? In the periodic table. What are compounds? 2 or more elements chemically combined. What atoms are in CH4? C is carbon, H is hydrogen, carbon and hydrogen. What atoms are in LiOH? Li, lithium, O, oxygen, H, hydrogen. Tick, cross, correct. Okay, you can pause or rewind at any point, remember. Mixtures. How is a mixture different to a compound? There's no chemical bonds. Name the 4 ways we can separate mixtures. So we've got crystallization, simple distillation, fractional distillation, and chromatography. Remember, you can pause to make sure you correct these if you got them wrong. Right, development of the atom. Describe the plum pudding model. Plum pudding model is a ball of positive stuff with lots of negative charges randomly scattered throughout. Modern model of the atom. What did they fire at gold foil? They fired the alpha particles. What happened to most of the alpha particles? Went straight through. What happened to some? They were deflected or deviated. What happened to a few? They were reflected, showing the nucleus is tiny. What did Niels Bohr suggest? Electrons orbiting fixed shells. And James Chadwick, that name I said you have to remember, he discovered the neutron. Why do atoms have no overall charge? They've got the same amount of protons and electrons. What is the radius of the atom? 0.1 nanometers. What's the radius of the nucleus? 1/10,000th of an atom. How many protons, electrons, and neutrons do each of these atoms have? So, protons for calcium, 20. Electrons, 20. Neutrons, 20. 40 minus 20 makes 20. For fluorine, 9 protons, 9 electrons, 10 neutrons. 19 minus 9, 10 neutrons. Okay, questions on isotopes. Let's go through the slides again. Atoms have the same number of protons and different number of neutrons. So this one's got 6 protons, 6 neutrons, mass number 12. Carbon 14 though, has got 8 neutrons, carbon 14. These are isotopes. So what is an isotope? They're atoms with the same number of protons, but a different number of neutrons. And then finally, plot these electron structures. Hydrogen's got 1 electron, so I just plot 1x. Helium's got 2 electrons, so I put 2 x's. Nitrogen's got 7, so I'll put 2 on the first shell, 2, and then I'm counting. So 1, 2 on the first shell, 3, 4, 5, 6, 7, so 5 on the outer shell. And boron, 1, 2 on the first shell, 3, 4, 5. So you can count up as you go. So 5 electrons, 2 on the first shell, 3 on the next shell. And then you can write the numbers 2, 5, 2,